For centuries, humanity has believed the Earth is round. We've launched satellites. We've circumnavigated the globe. We've seen images from space. And yet, in recent years, a growing number of people have questioned this assumption. Is the Earth really spherical? Or have we accepted something without examining it closely? Tonight, we examine both sides and the evidence behind them. And so, why do some people believe the Earth is flat? Before dismissing the idea outright, it's important to understand why some find it convincing. Many flat Earth arguments center around perception. When we stand on a beach, the ground appears flat, water appears level, and the horizon looks straight. From everyday experience, nothing feels curved. Flat Earth proponents argue that if Earth were curved, the curvature should be visibly obvious. Some also question photographs from space. They argue that space agencies could fabricate images. Wide-angle lenses can distort perspective, and they have not personally seen curvature. Another argument centers around flight paths, particularly in the southern hemisphere. Flat Earth proponents often claim that certain long-haul routes, such as flights between South America, Australia, and Africa, appear indirect or illogical on a globe. They argue that if the Earth were truly spherical, airlines would operate far more direct routes across the southern oceans. Instead, many flights appear to detour through northern hubs. Some also point to Antarctica, suggesting that commercial aircraft rarely fly directly across it, claiming this is evidence that the continent forms an outer boundary in a flat Earth model rather than a polar landmass. In flat Earth maps, Antarctica is depicted as a ring encircling the world. Therefore, certain southern routes would be dramatically longer than officially claimed, and some argue this is concealed. Let's examine one of the simplest claims. If Earth is curved, why don't we see curvature clearly? The answer lies in scale. Earth's circumference is approximately 40,000 kilometers. Its curvature is subtle over small distances. From ground level, you are too close to perceive large-scale curvature directly. However, there is measurable drop over distance. Ships disappearing hull first over the horizon is one classic example. If the Earth were flat, a ship moving away would simply shrink uniformly. Instead, the lower portion disappears first. This effect can be observed repeatedly and measured mathematically. If we look at historical evidence, we can also find more clues. Long before satellites, humans had already demonstrated Earth's shape. In 240 BCE, the Greek scholar Eratosthenes measured the Earth's circumference using shadows and geometry. By comparing the angle of sunlight in two cities at the same time, he calculated Earth's size with remarkable accuracy. This, at the time, was revolutionary, however, only required sticks, shadows, and basic mathematics. The conclusion matched what we now know to be extremely close to correct and can still be replicated today. So what about the flat Earth argument that space images could be fabricated? This claim assumes a global conspiracy involving multiple space agencies, independent astronomers, private satellite companies, thousands of engineers, and amateur astrophotographers. Possible, although a very stretched theory. However, Earth's curvature is not visible only from official images. Many hobbyists have captured the curvature using weather balloons and high-altitude cameras. Additionally, satellites are used daily for things such as GPS communications, weather forecasting, and television broadcasting. Their function relies on orbital mechanics consistent with a spherical Earth. To reject the globe model, one must propose a far more complex alternative system, one that explains every satellite trajectory, eclipse pattern, and gravitational model. No such alternative model currently matches observed data. Perhaps the strongest evidence is convergence. Multiple independent fields the following. 1. Gravity behaves as if mass forms a sphere. 2. Planetary formation models predict spherical shape due to gravitational pull. 3. Lunar eclipses cast a circular shadow from Earth onto the Moon, every time. 4. Time zones only function on a rotating sphere. Each of these alone is persuasive. Together, they are overwhelming. For Earth to be flat, an entirely new physics framework would be required, one that explains every observable phenomenon more accurately than current models. No such framework exists. So why does this belief persist? Partly because questioning authority feels empowering, partly because distrust of institutions has grown, and partly because online communities reinforce shared narratives. But scientific conclusions are not based on trust. They are based on repeatable measurement. The shape of the Earth is not a belief. It is a conclusion derived from geometry, physics, astronomy, navigation, and direct observation. In conclusion, skepticism is healthy. Questioning assumptions is valuable. But skepticism must be followed by examination. When we examine the evidence, historical, mathematical, observational, and physical, the conclusion remains consistent. The Earth is spherical, not because we were told, but because the measurements align. The real strength of science is not certainty, it is verification. This has been Hale Explains. Examining the world, one question at a time.